Hey guys, what are you doing in there? Zoom room this early in the morning. Oh, right, the HF Aeronautical presentation. Well, you're gonna have to give me a couple minutes. I'm not at the airport yet. I can fix that real quick. I'll be back.
Hello everyone. While driving to the airport, I thought I'd make this little video, little introduction or briefing, if you want to call it like that, on what we'll do today with the cameras and the videos and the part of the presentation we're going to have with you guys in the upcoming weeks. Once we get to the airport, we'll pull out the airplane from the hangar so we get better lighting. And I'll come around with the camera, get close and personal, and show all the details of the antennas that are installed in the airplane. We use different bands, so we use different antennas for those bands. And starting with the the most used antennas in the airplane, which are the VHF COM and VHF NAV. The VHF COM for the aeronautical band, it's just under 2 meters. It'll go from 118 megahertz to 136.97, so 137 megahertz, just under the 2 meter band. And the other VHF antennas we use are receive only, which are the VOR, VHF Omni Range. That's a navigation type of antenna. It works with ground-based systems or units or transmitters that send out two different signals. They're timed signals. Let me see if I can put it easily and super simple for you guys. It's a transmitter. Let's say it transmits 2 pulses per second. One, it's every top of the second. And the other one goes around 360 degrees every second. So it's like a, timed signal, like a directional signal, I would say. It's not directional per se. It's not an antenna that's rotating. It's the transmitter. It has different, antennas or inductors around the main antenna. And the offset of the signal will be interpreted by the receiving radio and decoded in a bearing from the station. So let's say you are south of the station. The pulsed signal will be received half a second later than the reference signal, and it'll decode that 0.5 seconds as 180 degrees. If it's a quarter second, you're on the east side. If it's 3/4 of a second, you're on the west side. That's just an easy version of how it operates. Yeah, of course, it's more intricate than that. It's not a second, but I use a second just to give the example and make you guys, use pretty more easy units on that navigation. That's a VOR antenna. It's receiving antenna. That also uses the ILS transmitter for instrument landing systems. When the weather is down low or the visibility is very, very poor, we use the ILS. That's an instrument landing system that uses the same concept of 2 different signals and a decoder in the airplane to give you guidance, lateral and vertical. Those 2 guys also use the VHF frequencies. The localizer, which is the lateral guidance, will use anything from 108 to 111.9 megahertz, the lower band of the VOR range. The glide slope, it uses, if I'm not mistaken, I can look it up and probably answer it later in the Q&A section of the presentation. If my memory serves me well, it uses also close to 300 megs, somewhere in the close to meter range, 315, 320. I'll dig it up and I'll give it up on the Q&A section. So those are the VHF COM and NAVs. Then we have the DME's distance measuring equipment, which shares the frequencies with the transponder. The transponder is a radio that we use. It's a radio. We don't talk over it. We select a code, and the radar on ATC side will see our airplane and identify us with specific code, so they know it's us we're flying. That operates in 1030 megahertz and 1060, 1030 megahertz and 1060, 1.03 gigs for interrogation and 1.06 gigs for replies. The DME, which is a distance measuring equipment, it measures the slant range, which means that it measures the distance from the airplane to the station, not the projected over the earth, which is something different. It would be like the shadow of the sun when it is overhead. This is the slant range, meaning that it'll measure the distance from the airplane, where it is up there at 40,000 feet or 35,000 feet or 3,000 feet, to the receiver. Yes, that is true. When you're over the station at 40,000 feet, which is roughly 8 miles, let's say 7.5, 8 miles, your DME will read 8 miles. So it will read the altitude. So that system operates in between 930 and 1260 gigahertz, or 1.2 gigahertz, 1.26. They share the frequency with the transponder. What else? The radio altimeter, it will send some pulses down to the ground and measure distances closer to 2,500 feet, 2,500 feet. So it is used for approaches and instrument landings. It'll give you, obviously, the absolute height over the terrain. There's been an ongoing issue with the 5G systems on the telephone, on the cell phones. They've been known to interfere with the 5G antennas and systems on the radio altimeters on the airplanes, and the FAA has issued a few alert bulletins, either canceling or putting on hold a few of the approaches, or the fine-tuned approaches, Cat 2, Cat 3 approaches into some airports because of interference issues with those cell towers around the area. So yeah, that's been detrimental to the airports that very often use those approaches because of the weather conditions that prevail in those areas. So the pilots either have to choose another approach, or they have to choose another runway with higher minimums for the approach. So let's say that the clouds are at 150 foot ceiling, and the approach that's not very trusty cannot be used. You'll have problems getting into the airport if the next approach available, the minimums are over that height over the terrain. All right, I'm getting close to the airport. I'm gonna see you in a few minutes, right when we get the airplane out of the hangar. See you later, guys. At the airport, Alex is taking care of the electro on the airplane. Across to the other side so I can get the nose strap and all that stuff. And we'll be doing that video shortly. This is the Aeronautical Mobile, one of the ones we use. November 82 Hotel and 2HH. We use phonetics all the time while talking on ATC. So there's a bunch of antennas that come out right away when you look at the airplane. A bunch of bumps on top of the airplane, a crooked antenna, another big bump, another big antenna back there, and down here. If you see an antenna down there, you're lucky because there are a bunch. So starting with the top, these two bumps over here are the GPS antennas, along with that third one that one over there in the center of the screen and that one over there in the center of the screen are ADF antennas, automatic direction finding. It's an automatic direction finder. It will put a pointer on top of the HSI, which is the instrument that gives you a bearing, range and distance to the stations. That will let you know where the transmitter on the ground is relative to your heading. That crooked antenna over there, along with another one right here behind the door, are the VHF COM1 and COM2 antennas. We have two VHF radios to talk with the tower here, and those operate in the 2 and change meter frequency, 2.7 to 2.3, something like that. Is 118 megahertz to 136.9785 or something like that, almost 137 megahertz, and that's the ATC VHF antennas. Coming on top of the airplane, another hump. That's the sat phone antenna, Iridium or Inmarsat. It all depends on the frequency they use, but it's high gigahertz. Can't remember exactly what frequency, but we can discuss it on the Q&A section on the presentation. That's an HF data link antenna. It operates between 2 megahertz and 10 meters, between 160 and 10 meters. There's other versions of the data link that use satellite and VHF, and the SAT frequency is going to be discussed also, and the VHF frequency, it uses 136 megahertz and some odd number after that, 136.585 or something like that for data link. And back here we have another antenna which is often used for the ELT. The ELT is a radio that operates in a VHF frequency, and nowadays it also operates on UHF to be used with satellites. The ELT is emergency locator transmitter. Something happens, that thing will go off and it'll transmit the signal so the SAR crews can find us. And that little antenna back there, it's a marker beacon, another radio aid for landing under instrument conditions. That'll help us determine our position along the flight path to the runway. And finally, back there to the tail, we have the leading edge on the vertical stabilizer, which is the antenna for HF communications in the airplane. It's a notch type antenna that is driven by an antenna tuner, or an antenna coupler as we call it. A big unit back there. I'll show it to you later in pictures, that manages to tune that piece of metal and make it work as efficiently as we've seen before on the Aeronautical mobiles. Back there in the tail section, vertical tail, the elevators, we also have a few of those that be popping up. And right here on the wings, we have the so-called static wicks. The static wicks help us dissipate the static electricity that builds up in the airplane when it flies through the air. Static electricity builds up with friction, and if it's clear air, not much of a static electricity will build up in the plane. But when you're flying through clouds and ice crystals, the amount of electricity that builds up in the airframe is huge, and it's enough to blank every single radio operating inside the aircraft. On the right side, we have a better view of the antennas, vertical stabilizer, and that little wing in there is the VOR antenna. That's another VHF receiving antenna for navigation purposes. VOR means VHF Omni Range. Once again, the antennas from the right side, VHF COM, ADF, GPS, ADF again, And on the right side, bottom, the VHF COM1, VME antennas, and transponder antennas. Let's get to the bottom here and show you the radar altimeter antennas, which operate in the 5G band. This flat one here, and the other one back there, 5G antennas. They send a directional signal down to the ground, and they will bounce off the ground, and based on the time that the radio determines from the transmission to the reception of that signal from the antenna, it'll give you a distance or an altitude from the ground. Airplane's fueled up, pulled up in front of the hangar, ready to go. Let's go around it and check the operational status of the airplane, okay? Come out of the main gate, main door, check the general condition, no scratches, bumps, missing parts, nuts and bolts, everything. The pitot, which is the sensor for the airspeed indicator on the captain's side, it's clean, nothing sticking in there. The nose gear, the scissors, the tires are good. The strut is not leaking, it's clean, everything looks good. No flat tires, the nose is good. We have no scratches, no bumps or anything broken or missing, all good. General condition, no leaks. The O2, the right side pitot tube is also good, clean. The removed before flight streamers have been taken out. The AOA vane, it's also clean, good, and in the ground position. The static ports on the right side, they also have to be clean. These guys measure the static pressure from the air when you're flying, whereas this thing here, the pitot tube, measures the dynamic pressure. Both of those things in conjunction with each other will give you altitude and speed. The antennas and the belly of the airplane, all in good condition, nothing broken or hanging loose. The leading edge of the right wing, also good condition. The boots are very well maintained, not broken, and sticking to where they have to stick. The right main landing gear, 2 tires, good condition. The light, all the rods, connecting rods and bolts and nuts are good. No leaks under the brakes. Under the wing, we take a look, everything good, also no leaks. Good condition, coming right around the right wing. The lens for the nav lights are there, no scratches on the wingtip, winglet or anything. The 4 static wicks are in place. The aileron looks good. The flaps with the actuators and the Cushman carrots, they're in place, they're looking good. The fueling panel is latched closed, 2 up here and 2 on the bottom. The brake assemblies are also good. No leaks, everything looks good on the strut and on the gear well. Tires are good. You go back here, again under the fuselage, no hydraulic leaks, no oil leaks, spanking clean, that's how we like it. Go up here, nothing stuck in there, no debris, no birds nesting, nothing. Generator inlet, it's also clean. Drain mast is also clean of foreign debris. Truss reverser, the right leading edge on the right horizontal stabilizer with its 4 static wicks. The vertical tail is also good. The exhaust is clean. No remove before flight streamers or caps in there. Elevator's looking good. Rudder's looking good. Trim tabs aligned. The OR antennas up there. Tail section, both engines looking good. Left elevator with the left horizontal stabilizer, the 4 wicks also there. Come back up there to the rudder, vertical stabilizer. Tail looks good. Trim indicator where it should be indicating. The accessory well cover and doors closed. The cargo compartment is open. We're waiting for the bags. Once again, the left side, generator inlet and engine inlet. Nothing in there, no birds, no nothing, no stones, no cell phones, no keys. No teddy bears. The left gear, also good condition. Everything's in place, no leaks. Good amount of strut showing right there. The gear well is also good, tidy, nothing, nesting in there. Under the left wing, also good, no leaks on the ground, no apparent damage. The carrots are good, tracks are good, flaps are down. Yep, go ahead. The left aileron looks good. Sounds good. Left wing static wicks. The leading, the winglet, leading edge looks good. Slots are deployed. The left hand nav light and strobe light lens is looking good under the wings. No leaks, good condition. Everything looks to be in place. Leading edge flap. Alright, we're getting it online. That's the hydraulic pressure, hydraulic pump to lift the hydraulic pressure for the brakes. Left gear looks good, just as the right one does. And under the airplane, left side static ports, they look good. And that concludes the quick walk around on the airplane. Now you have to get it running. That's Alex doing the tests and the checks in there before cranking up the APU, which is the auxiliary power unit. Will give us air and electric for the systems before we crank up the engines. I'll see you in the air. Now sitting inside the hellhole here, which is the aft cone of the airplane, which contains a bunch of the systems needed for, safe operation of the flight's hydraulic systems, power supplies and other things like these orange boxes, which are the ELT and the flight data and cockpit voice recorder. Black boxes, you know what they are for. And the HF system, this airplane is installed with the KHF 950. This is one of the parts for the system. This is the receiver transmitter, or as they call it, the receiver exciter in the manual. That's the main computer for the HF. That's the one that's connected to the head in the front, in the cockpit. And this one, it's also part of the HF system. That's our antenna tuner. We call it the coupler. The coupler works with solid state capacitors inside to tune the appropriate frequency we're requesting from the cockpit. It's filled with inert gas nitrogen to isolate it from humidity, since back here you get temperature swings that go from like 140 degrees to -70. Condensation and humidity might play a bad role with electronics. If we try to go to the other side here, we see the grounding strap, and probably, I don't know if I have this good, the antenna connector up there. And that one goes to the antenna up in the vertical stabilizer. The antenna is a notch style antenna, which is the one they use for that application. Hey, once we are inside the airplane, the cockpit, I'm going to show you how to start her up real quick, and then we'll run through the checklist. When you get into the cockpit, the first thing with the landing gear handle is in the down position, and then we're going to select the parking brake to park. All right. Now we come to the overhead panel. We go to battery override load reduction, and then we kick open the APU door. Everything's going to come online slowly but surely. And then when that thing finishes the boot up and the colors are pretty, we have that cast line that says APU door open. Now we get the right hand standby fuel pump so we can feed the fuel to the APU, and we start the APU. You're gonna see the RPM and the temperature come up here. When it reaches 98, you're gonna see APU available in green on the CAS messages up here, in the top right hand corner. APU ready. So now APU generator, avionics masters 1 and 2, Beamer battery on, bring the other fuel pump on, check the lights, and get the FMSs running. My HF is running already, and that is how you bring the airplane online from a cold start. Hope you like it.